You never know what's gonna happen with these as far as who's gonna show and who isn't. Okay, so we want to. It's been, as Doug was mentioning there, it's been a while since we've met up. And what we want to talk about today primarily is to do with uh, our remote control vehicles that we have purchased, or a vehicle, and starting to get that interface to the motors that are stock or native on the platform, and getting started with Arduino for the ultimate controller of that. So that's where it is that we are in the flow of and the context of this meeting. And so what we want to do here is talk a little bit about. Okay, so let me just give you kind of the agenda itinerary that I've got planned for today. Is to do some basic attendee queries as far as asking some questions as far as where you are in your journey with your vehicle and what you want to do ultimately for motor control. I want to outline some recommended tools that I have for suggestions for you, and then I have a few education points that are related to this whole working with Arduino in productive ways, and specifically to do with motor control and all those kind of things. And then I have some share points that I want to make about my own platform that I've been in the process of working with for this conversion project. I want to give you guys status on that. And then in general, I want to open the floor for questions, for comments, that kind of thing. So let's re-roll back up to the top, and let's talk a little bit about where you guys specifically are at with this project, with your vehicles. I know both Doug and John have purchased vehicles that are specific to this project. And so hopefully both of you will have some status. And Dave, I don't know about yourself on this, but maybe you can kind of edify us all a bit about where you are in your project, what it is specifically that you've decided to do about motor control, if you wanted to only stick with autonomous control for the motors, or if you are like me and you want to have a user switchable kind of scenario for being able to switch between a remote control scheme and then do a toggle switch change and move over to autonomous control only. I mean, instead. And so I'm kind of curious about where people are on all this, and kind of do a kind of a general catch up in that area.
So for me, um, I'm not specifically building an RC car. I
Okay.
do have one I picked up somewhere. Um, I was helping out some high school kids, and they were looking for a project. Um, but for me, it's mostly I've every now and then I just search Meetup looking for interesting groups, and stumbled across this one, and I thought, okay, well, I'll come and see what's going on.
Hmm.
And
Hmm.
you never know, you pick something up or find new people to meet with and that kind of
Right.
thing. So that's
Exactly.
what I'm about.
Okay.
Um, I
That's
actually
fine.
work for a company that manufactures satellites, and I'm doing all the embedded control software for the
Hmm.
satellites. So I do lots
Hmm.
of low-level embedded programming, and also some motor control because we have an antenna pointing mechanism that uses stepper
Hmm.
motors.
Hmm.
So.
Right. Right. Okay. Cool. Well, we're glad you're here, Dave.
So let's see. I talked about my RC car that I got last time. Um, uh, what I discovered last time was that although it had been billed as a two motor car, it actually has three motors if you include the steering motor.
Oh,
So we'll need three H bridges. So I don't know. I know they come in, some of them come in pairs and some of them come individually, but I guess
right.
a single
Okay.
and a double or something. I'd like to try and find something small enough that'll fit on the body. So, but I haven't done any real searching through your literature or whatever to try and figure it out.
Okay.
Uh,
Okay.
so I had something else to do in the meantime as well. So uh, time to get back to this. I haven't been doing anything else. Um,
Okay. Let's see. So Doug, uh, let's see. In fact, maybe you could come on camera to demo a little bit of the insides of this platform that you're speaking of. But
oh,
I'm curious about this idea about three. I understand that there's definitely a motor for drive control. Then there's definitely a second one, at least for these platforms, that's dedicated to steering. Okay, I get that. But I'm a
well,
little bit mystified about this third motor that you speak
oh,
of.
so it's a four-wheel drive vehicle, and it said it was two motors. So I assumed there was a mechanical connection between the front and back wheels, driven by one motor, and the other motor would be the steering motor. But it turned out they don't have any mechanical connection. Instead, they have a motor in the front end and a motor in the back end, and then an additional steering motor. So I'll need two drive motor. I mean, I could conceivably put in one H bridge and drive both motors with it, and I guess that is a possibility. But I think I would prefer to have a separate H bridge for each of those motors, and so then there'd be three total.
So this idea about the steering mechanism, I get what it is you're referring to there. But where does this third motor
Oh,
that you are
oh, so
talking about, how does all that fit in with this scheme about the topology for the overall, drive capabilities of the platform?
so the back pair of wheels is driven by a motor, and the front pair of wheels are driven by a motor, and then the
Mhm.
steering is driven by a motor. So those are the three motors.
Oh, okay.
So
So I
like I
would,
was saying, I could conceivably connect both the front and back motors to the same H bridge, but I think I would prefer to try and have a
Yeah,
separate H bridge for that.
right, right. Right.
so
Well,
I would expect,
for one thing, I would I'm sorry to interrupt whoever was starting to speak there, but let me just get out one little thing here. Yeah, I suspect too, Doug, that it makes the most sense for drivability for power, depending on what it is ultimately that you do with this platform in an autonomous way. Once the, Arduino or Arduinos are added in, is for the idea about more powerful. It's a more powerful platform with the idea about this more sophisticated drive tech topology that you've got on that platform, to have two separate controls as far as front front drive and then separately rear drive. Uh, that they can both be powered, either one half of the drive or both to be able to get out of tight spots and all that kind of stuff.
I'm gonna try and go find my device because I think what I had determined last time is that there are no differentials in it.
Mhm. I see.
so I was just going to say the sizing of your H bridges, I would anticipate that the drive motors are going to use a lot more current than the steering motor. And so you may find you want different H bridges anyway, for the steering, just because it's probably a smaller motor.
And should take a lot less power.
Yeah.
Even if it took as much power, it would be for, well, actually, it's hard to say because I think, well, I don't know. It's not a servo, right? In the original device, the steering wheel is connected to a switch. So it's center off, and if you turn it to the left, it makes a contact, and you turn it to the right, it makes a contact. Now, I intend to do that proportionally with my motor controller. But to do that, I will have to do that myself by turning off the power, allowing it to center. There's a spring that centers it, and then turning on for a short period to get to a certain steering angle, because I want to try and do better than the original controller. The original controller just locked left or right, because there was no way to avoid that. So I want to see if I can actually get fine steering angles by uh, pulsing that motor. Turn it off to let it center, and then turn it on for a short period to get it to an angle, and see if I can do that quickly enough that it doesn't jitter. I don't know what that would be like, but it's something to try. Basically, to control the angle by the length of the pulse. Basically, I'm pulse width modulating my drive to the motor and hoping that there will be a proportionality between that pulse width and the steering angle.
Mhm.
And so let's see. Oh, here. So I found my device, my vehicle. Yeah, the wheels are locked to each other. Actually, the back pair, there's a little bit of oh, you know why? It's the steering on the back. Um, there's no steering, and so the axle goes straight through. On the front, we have to go through the U joints in the steering, right? There are U joints on each side to accomplish the steering, and so you can feel that when you wiggle the wheels. But there's no differential, and that makes sense because it's supposed to be a rock crawler, right? And rock crawlers, they actually go in and weld the differentials on the real full-size vehicles because they don't want a wheel that happens to be up in the air to spin and lose all the power. Uh, and so I'm hoping that this vehicle, which is billed as a rock crawler, although when you buy the thing, what you end up with is something that's way faster than something of that scale should go. A real crawler would go very slowly through some very tough rocks. This does have a very nice suspension, so that I can put it on a table and lift up one wheel, and it does not lift the other end. So that means that I should be able to go over some reasonable rocks.
Mhm. Yeah. So Doug, do you have any of these three or less than three motor controllers purchased at this point, or are you still in
No,
research mode?
yeah, I'm still in research mode. I need but interesting that I should try and figure out, like with an ammeter or something, get some idea of how much power I need to provide to these.
Mm-hmm. Right. Um, so one, let's see. So I've got a couple of points that I want to make before
Okay.
before we move on that. So
Hey, Donna,
yeah.
I'm wondering if you could help me out with something first. I'm connected right now with my phone. However, I do want to use my computer, but I don't know the meeting ID and password. So sorry to interrupt the whole thing to do
Okay,
that.
that's all. Well, it's all right. I will forgive you this time. Okay. I,
Okay.
I'm trying to be funny here. Let's see here. So where is that? Boom, boom, boom. Well, I'll tell you what I can do, John. Is I
Hmm.
can log in on my other computer into Zoom and I can identify. I'm assuming, John, that what you want to do is have the meeting ID meeting ID set a string of numbers, and then separately you want to have the meeting passcode string. Is that what it is that you want to have, or do you want to have the
Yeah.
actual link itself, the join link? Which one do you
No,
want?
no, the meeting ID and password.
Okay, all right,
So I'm on a
okay.
computer that I'm not using my email
Okay,
with.
so let me finish up. Let me finish up with my trail of thought here first for Doug's item,
Okay,
and then I'll go over to the computer and I'll work on that and I'll get that set up for you. Okay.
thank you.
So what I was going to say, Doug, is what you want to watch out for. And this is what I recently found with my little platform that I was working on, and I've had to, for what it is my original design was for that particular platform, I've had to scrap that and move on to something different. And I was going to give status on that later. But what you want to look for with that steering motor out of the three, you want to make sure that there isn't something weird going on there as far as you needing to supply additional um, additional commands besides just the two motors. I'm sorry, besides just the two lugs for each motor. I'm assuming we're talking about just general DC motors for your three that are on the platform. And we're not talking about stepper motors. We're not talking about something else. Because what I found out with my platform, again, I've got something real cheap, I've got something real old that I was trying to work with. Okay. And I was trying to keep the inexpensive PCB board that was on there
Right.
for the RC circuitry. Okay.
Yeah.
Because this platform I was using was not using any of the standard RC industry parts. In other words, it wasn't using a separate ESC part. It was not using a traditional receiver part. Okay. So it wasn't doing any of that. It was literally on the PCB board itself. Okay. And so what I found out with my steering motor, even though in both cases I had DC motors. Okay. And I didn't realize until I actually got in and debugged what was going on with the platform is that for my steering motor, is that it's a cheap implementation, but effective for the manufacturing. Is that what they did was that they've got a modified DC motor that performs as a servo motor. So that servo motor, as far as the arm, the actuator arm for the steering, as far as left or right versus straight command,
Right.
for the three positions, is being controlled by a homemade, so to speak, uh, servo type situation. And so what my PCB board on my platform has is a 5-pin ribbon cable that's going off to that pseudo servo motor
Oh,
that provides the commands for centering, for how far right, how far left that the RC transmitter is actually putting forth to the vehicle. Okay, so what it is I'm getting at is you want to make sure with your platform that you don't have any of that going, that you only have two lugs per three motors that in total that you can strip out or augment what it is that's already on the platform to add in your H bridges to that will eventually be controlled by the Arduino. Okay.
yeah. My
Um,
motors are plugged in with little connectors, and so there's two wires for each.
mhm. Okay. All
So
right.
I'm interested in yours, though. It sounds like yours is a lot fancier than a cheap RC car should have.
Well,
Uh,
yeah. Well, okay. I mean, it's
you
okay.
could now that sounds actually closer to what I had years ago with the first RC car that I modified and put in a basic stamp. And what I did is
Mhm.
I identified on the single PCB like that. I was able to diagram the circuit and find the register that the receiver was storing
Mhm,
like
mhm.
5 or 6 bits of data in, and then
Right, right.
able to cut and slash the traces on the outputs of that register and wire in the ports of the basic stamp so that they could read the output of that register
Yep,
and
yep.
then
Yep.
replace the register as the source for the things that it was originally connected to. And then my first program for that basic stamp was read the inputs and write the outputs as fast as you can, just in a loop. And so then I was able to try the RC controller to see how well the car worked, and
Hmm, hmm.
it
Right,
worked
right.
well before. And then all I did was oh well, then we determined by looking at the circuit in the controller that there was a button that had not been implemented. It was on the circuit board of the controller, but not on the plastic body of the controller. And so we added a button, and it turned out because of the homebrew um, RC protocol that they had used, all I had to do was add one diode to get that extra data bit through, and then I used that as the shift key. So when I pushed that button and did a motion with the joystick, that could be identified by the basic stamp as a special command, and that allowed us to say, you could use the RC controller to say, "Oh, go draw a square" or something like that, and it would go and draw a
Hmm.
square. And then if you didn't push the shift key, it would just operate normally.
Right, 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 right.
But
Anyway, thank you. Excuse me, but thank you, Dave, for putting that meeting ID and passcode into the chat. So this is what it is that I've got going online, Doug.
Mhm.
So here is the PCB itself that I wanted to keep on the platform.
Right.
Okay. And then here is this steering motor mechanism
Well, it sounds
that I
more
was,
like a servo if it's got 5 wires to it.
yeah, well, right. It is like it. That's what I was trying to say. It's a manufactured, inexpensive for them at the time that this was manufactured. It's a
Right.
cheap version of a servo
Hmm.
that allows for this, either straight or
Hmm.
full direction one way or the other for the steering.
So
Okay.
if you wanted to, you could like hook an oscilloscope to it and try and figure out how to talk to that servo, and
Right.
then
Exactly.
that would
That's
be a
right.
boom.
Exactly. I understand. I understand. But anyway, I so that's what it is that I've got with mine. And I was just trying to say that if you've got a scenario like that, Doug, on
Yeah.
your platform, that's a caution point that you need to mitigate and come up with a solution for, because it's not going to be just a direct plug and play if you don't have just only the two lugs per DC motor for drive control that you want to directly interface with a Arduino shield for motor control. It's gonna be more tricky. That's what it is I was getting at with the divergence that I had there. Okay. Okay. And the other point that I wanted to make, I've completely lost track of it. Exactly what it is I was going to speak of. So I guess I'm done speaking for right now.
So John, you replaced your steering servo, as I recall.
Yes. Yeah, I just put a little hobby servo for doing the steering. Um, okay, I'll just show a picture here. That,
So, John, are you now on your computer and not your phone?
yes, yeah.
Okay, cool.
Oh, will it focus? Oh, it's probably in that because of my background thingy.
Yeah, you've got your background blurred.
Okay. Let me see here.
You got to do none for virtual background.
Okay. Use. Okay. Okay. Background.
There you go.
There we go.
Okay. All right. There.
There you can see it. So I just made a little uh, mount for the servo. And then glued that mount to the top of it.
Let's see, how is that connected to the linkage? Oh, you just have the horn aimed down?
Oh, yeah, I see it.
Right. Yeah. In fact, you used the original lever from the original servo, right? And figured out how to mount that on the horn.
Yeah, I did have to um, cut off a piece of the old one so that it would, and then cut off a piece of the horn that it goes on this servo and
Oh, and glue them together?
the two pieces together. Yeah.
Ah, you did a good job. It looks like mine.
Yeah, it works. It works fine. So,
So now you have to be careful not to tell your servo to go too far. It would be in conflict with the limits of the
yeah,
steer.
sure. Yeah.
And by the way, that's what it is that on my particular platform, that's what those 5 pin, at some future date, I'll try and debug and decode what those 5 pin signals really are indicating for the limits. But that's part of the design of this platform, is that those 5 individual command set is limiting in either direction, so that the platform isn't damaged, so that the drive
Right.
motor is not commanded too far either direction. So that's what's designed automatically in my platform on that PCB.
It could even be that um yeah, that the 5 wires, well, I can see the 5 wires could be 2 wires for a plain old motor.
Well,
And
actually, in my case, it's not, Doug. There are 2 separate pads on the PCB just for the motor itself. And then there's the 5 pads for the control mechanism.
no, I mean the steering motor.
Right, that's what it is I'm talking about.
No, no, but what I mean is you've got 5 wires that are coming from your steering unit, right?
Right. And then separately, that's what it is I'm getting at, is that then separately, there's the 2 pads that are connected to the DC motor itself that are separately
But
soldered to the PCB.
are you talking about a DC steering motor or are you talking about the
Yeah,
driver?
I'm talking about steering only here. Okay.
Oh. So you got 5 wires to understand besides.
That's right. That's what it is I'm getting at. Yeah.
Well, that's a lot. I could see 3 because then you could have
Right. I know. I understand. Yeah. I know. Anyway, so that's a little bit of a challenge. That's for sure.
Hmm. So you can see on John's vehicle there the substantial suspension.
Yeah.
And yeah, you just lift one wheel and you'll see that the other wheel, the far wheel, does not lift.
Mm-hmm. Mm-hmm.
And so that's the uh, I've actually been watching. There's a YouTube channel called Grind Hard Plumbing where they build rock crawlers.
Right. Our plumbing.
Yeah, in fact they've for a project that they were commissioned to do, they bought some very large wheels and built a four-wheel platform using it, and then that fell through. So they were left with these 4 large wheels and wondering what to do with them. And so they ended up building a motorcycle. It's like a monster motorcycle. It has giant wheels. Each of those wheels mounted to the motorcycle only on one side. So like they use the normal steering you would for a truck on the front one and hand built connection to the back one. So there's no visible connection to those wheels on the left side of that vehicle. and then a motorcycle engine from some other motorcycle in the middle. So quite a deal when you're driving down the road with it. All you see coming at you is this giant wheel. And then were left with two wheels left, so they put them on the rear end of a Humvee, and they connected that to the engine of a diesel engine from uh, uh, a VW diesel engine. And then for the front wheel, they got the largest tractor tire they could find. It's like, I don't remember, but it's taller than a person. And they hollowed out the hub for that wheel and mounted the driver in the middle of the wheel. And so it's a tricycle that you sit inside the front wheel to drive.
Anyway, Doug, did you have anything else that you wanted to share about your build and where you're at? And
So, well, that's where I'm at, is that I need to get my multimeter wired in there and measure the current to these motors and
okay. Oh, I know what it is. What else it is I was going to say to you originally about that
okay.
is one advice in general is that you can go by as far as the current needs, the voltage need, and all that kind of thing for the individual motors.
Uh-huh.
Is that you can go by the the by spec, the stock implementation of the battery or batteries that are required to operate your platform. I'm assuming that this platform, by the way, that you purchased is a regular RC unit. Is that true, or was it specifically designed for robotics? Without
No, it wasn't designed for our robotics. I had a choice of different kinds of cheap RC cars, and I picked the
Mhm.
one with the largest voltage of the battery. I believe it's 7.2 volt.
Right,
Uh,
right, right.
the idea that I could conceivably find a low dropout regulator that would run the Arduino off that. I don't know if I will, but that's at least a possibility.
Mhm.
And
Okay.
um,
So
hmm,
so what it is I was getting at, Doug,
mhm,
since it is an RC industry vehicle, is that what you can readily do is go by the battery pack that either came with the vehicle itself, or if you needed to buy the battery pack separately to go with the vehicle, is that you can go by the spec needs of voltage and current that's required of the battery or batteries for your platform, and judge your motor controller boards off from that. And what I do in general is based on the battery for the vehicles that I've got in my workshop, is that what I do is I take that battery pack and then I factor in like a at least a 30% more for both voltage, maximum voltage that could go through the controller board, and also the current draw, and then base my motor controller needs based on those numbers. And then rather than you sure it's a good exercise anyway to probably go through with an ammeter and actually see what the real draw is for each of your motors. Okay.
well,
But
so
if you want to just have just a general back of a napkin kind of determination, going with that battery need is a good first step.
So how do you get the current spec for the battery? These are just lithium
Well,
ion
okay. Well, I
cells.
mean, all right. Well, so was there a battery that came with your platform, or did you need to buy one separately?
No, it came with it. It's a two-cell lithium ion. It has three wires to it, probably so that there's a sensor so that you can safely charge the lithium ion cell. But it's a two-cell lithium ion pack, 7.2 volts as I recall. 7.4 volts according to the little
A little.
box
Uh,
to put it.
okay. All
Oh,
right.
and interestingly, the connector, yeah, there's John showing the same pack. Interestingly, I just noticed that the connector that is inside the battery box of the vehicle only connects to two of the three wires. So that means the other wire is only used by the
By the
power.
charger.
Yeah, and the power
Yep.
pack on this thing is USB and does indeed have three wires. So that
hmm
I must be
hmm
right that the third wire is there just to
hmm
uh,
hmm
provide the sense.
Okay.
You don't have
So, okay, so I'm assuming then, Doug, also that that battery pack that you're speaking of does not per se have a label on it other than that 7.4 volt statement that's on there. I'm assuming it does not specify what the amp hour rating is for it.
it does
Because that's
yeah.
what it is I'm getting at is you need to look at the amp hour rating.
In the ad, it says how long you should be able to drive the car on a charge. I'm seeing here now that the little charger unit says 7.4 volts, 500 milliamps, but that's the rate of charging. And then you'd need to
Right.
know um, you could probably discharge it quicker and of course that doesn't give you a time either. So yeah, I'll measure it with an ammeter because I
Yeah,
want
you need to root out what that amp hour rating is what it is. I'm trying to
well, the
uh
one thing is that if I hold the wheels so they don't rotate and then power them with an ammeter, then I get the actual short circuit current, which would make
Yeah,
sense for a rock crawler because
I
you're
did
not.
that, Doug, with mine, and I posted those numbers
Oh,
on the
on the
Discord.
Discord.
Yeah.
oh, that's a, by the way, I've been having trouble with the Discord. I haven't been able to get to it, and I don't think it's anything to do with this meetup because I've had the same problem with Discord from other places that I use it, and I'm not sure what's going on there, but I haven't been able to get to the
Hmm.
Discord.
I haven't logged into Discord for quite a long time, so so I don't know.
Yeah, I haven't tried it for at least a month as well.
Well, here, I'll put it in the chat.
Oh, that'd be great. There we go. 8.1. That's a lot.
Yeah, that's with the little battery um is fully charged. It's a 8.1.
Ah.
Mm.
Oh, and the steering motor as well. Very good.
And the two drive motors are obviously the same. They're identical motors. So
Did you test each of the motors separately, or did you have a way to hook to both of them at once?
Let me see here. I just oh, you mean talking the the drive motors?
Yeah, the drive motor is a front and rear drive motor. So did you connect to one of them or both of them or?
I just think they're both the same. I think I just did one of them.
Oh, okay. Yeah, there's no reason for them to be different, although of course the container is different. The the plastic container for the rear end looks like a differential, even though there's no differential in there. Oh, it's probably there is probably a right angle drive there. Actually, I don't know. No, it shouldn't need a right angle drive because the motor is transverse. One of the things I mentioned before is that this is very highly modularly constructed with lots of screws. And so one of the possibilities, since Donnie, you had us buy two of these, is that I could replace the rear end on this with the front end from the other vehicle and have a four-wheel steer device, four-wheel
oh
drive
yeah,
steer.
That would be
right.
cool.
Wow. That's good that it's that platform that you chose is so modular. That's unusual.
Well, yes,
Uh,
I
you
was
know.
amazed when I found it because they in the ad they say it comes with a screwdriver, and ostensibly you need that to open the battery doors on both the vehicle and the remote control. But
Yeah.
when I saw the construction in here, I realized that as soon as a kid became bored with the vehicle, it would be all apart.
Oh, that's funny.
Which is entirely what creates people like us.
Yeah, that's right. Yeah.
So on mine, I did purchase the motor driver and some voltage regulators for it, and hooked it up and um, used one of the example codes for driving the motors, one of the example codes that you sent. And I can show it to you if you want.
Oh, that would be great. Let me make sure that that share screen is available here. Okay. Yeah. Okay. So yeah, you can you can share a screen now. Anybody can.
Oh, okay.
I didn't have that by default. So
I'm
that,
just going to use my camera here anyway. So, well, yeah, I could do the share screen. Let's see here. Share. Maybe I can. I'm always confused. I'm using two monitors and it's always confusing. Um, yeah, I'll just, so the code is really simple. All I'm gonna do is enter, are you guys seeing that backwards?
No, it's looking good.
Oh, okay, that's interesting. So in this example code, all you do is type in a direction for by putting in a plus or minus and then a number from 0 to 9. And so here, a robot, and so I'm using an ESP32. Eventually it'll be connected to with Bluetooth to a phone where I can just drive it around remote control or send it like example code to do particular routines. But anyway, here is moving forward, say at 4. I think it's actually moving backwards. I just have to switch the fire with a little bit. That code looks really nice.
So, so far you've only connected up the back wheels?
No, I can connect both of them. I just don't have it that way right now because
Yeah, I just noticed one wire, one cable.
yeah, the little motor driver does drive two motors.
Hmm.
Um, don't ask me what the specs are on it because I don't have it in my head. And then it'll also, I have it so that it will, I can control the servos to the little servo for the steering. Anyway, that's as far as I've gotten so far.
so ultimately, John, have you decided what you want to do for are you going to do autonomous drive only, or are you going to do a user switchable between a remote control versus autonomous drive?
Yeah, so on the phone, I'll have something, get my a little remote control app.
Hmm. Okay. So you're going to do Bluetooth for your wireless communication.
Yeah, just like a little controller that will like I can drive it around with this little
Mhm.
Pretty cool.
app thing, and then able to switch also to like doing specific routines.
Hmm.
Right.
So I'm going to try to appease my little one board receiver in the car, make it think that it's got motors connected to it, so that I can receive the command sent from the controller and then get that into the Arduino so that I can do either RC or autonomous.
Okay. Okay.
I'm not
All right.
sure how to.
Uh,
I'll need some way to switch between RC and autonomous because I don't have.
Right, right. Yeah. So we're going to be getting it. Yeah, we're going to be getting to that. Um, okay. And so I'm assuming, John, because I think John, you and Doug both have the same vehicle.
Yes.
And so do does your vehicles have standard RC equipment with them? In other words, you got your transmitter unit that's off platform, and then on the platform itself, there's multiple probably ESCs, and then for the motor control, because that's typical of the RC industry, and then also a receiver unit. Is that what's by default or stock? Is that what came with your platform?
No, it's one little board
Oh,
in the
okay. So
car.
it's kind of similar then to what I've got as far as a PC board that's on there then, right?
But when I bought one of these years and years ago and put a basic stamp in it, that had discrete parts driving each of the motors and like yeah, that's what this one has. So it has one chip that does everything. It uh,
Wow. Okay.
it implements the receiver. You can see that little black wire that's hanging off there.
Yeah.
That's the antenna, 2.4 gigahertz antenna, and and then that one chip drives the steering motors and the drive motors, uh,
Right.
all from the one chip. So what I will
Okay.
need to do is, because I intend to keep that, what I'll have to do is do whatever I need to do to make that chip happy, even though I don't have motors plugged into it, and then see if I can receive signals from it so I can tell whether the
Right.
transmitters turn left or turn right or go straight, and
Right.
and then get that into the Arduino inputs. You'll
Right.
notice that there are four connectors on this. Two of those are for the front and rear drive motors. One of them is for the steering motor, and then there's a large connector, a 4-pin connector there, which I believe is to control lights. Um, um, and there are no lights on this particular car, but that doesn't mean we couldn't add lights. We have to figure out how to drive that. Now, the RC controller has no way to turn the lights on and off, so we'd have to figure out how to add that.
Mm-hmm.
The
Mm-hmm.
lid off my controller here. Now,
Mm-hmm.
I have to do that. John doesn't have to because he's using Bluetooth. But I'm going to try and
Right.
use the original RC
Right.
controller. And I guess I don't have this. I must have put it back together because it's got a screw in it. Oh no, that's the battery door. I should be able to pull this apart here. Just a moment. Yeah, there we go. So the controller comes apart, and on one side you have the brushes that are attached to the steering wheel and the trigger, and on the other side you have a single PC board that has a surface mount chip that is the transmitter. And um, so the brushes that are on the trigger and the steering wheel, they wipe on the back of this printed circuit board, and so that's how you can see that it's just implementing two center off switches. So your only choice is full blast forward, full blast reverse, full blast left, full blast right, or
Mm-hmm.
or stop. So
Mm-hmm.
that's why I want to try and use pulse proportional get this vehicle to drive much more slowly than it was
Right.
designed to
You're
do.
right. Right.
And I don't see at first look any unimplemented circuitry. And wait a minute here. There is something that looks like a button. Gosh, if that's a button, I've got a possibility here. No, I need a light. There is something that is extending out of the bottom of this. Oh, I see. That's where it's mounted. It's just one of the plastic pins that locates the PC board before you put the screws in. So I don't see anything on this PC board that looks like unimplemented controls for the lamps. So that'll be a challenge for me. Try and figure out how
Okay,
that.
so what kind of transmitter, since this is RC technology by stock, so okay, all right, yeah, no, that's a traditional RC transmitter, that's for sure. Okay. Okay, yep. Okay.
So,
Mhm.
but this is nothing. It's not any standard. It's whatever they wanted to do to cheap, right? It's a
Mhm.
single board um, uh, controller and a single board receiver, and they picked whatever protocol they wanted to.
Mhm. Yep.
Um,
Yep.
The
Right.
like I mentioned, the one I modified years ago had a very rudimentary um, homebrew uh, RC protocol that sent bits in a train, and I was able to figure it out with an oscilloscope.
Mhm. Right. Yep. Okay. Okay. Dave, did you have anything to chime in on before we move on?
Nope.
Okay. Okay, so let's go ahead because we're already about an hour in here, guys. Why don't we go ahead? Let me just cover some other points here as far as some edification things. Let me go ahead and share my screen here about I have a video to show you all
Ooh.
For some ways to power your Arduinos. Very let's see. Okay. Very good information here. And I'll be sharing both in the chat before we leave today and also over on the Discord server. I'll be sharing the links. Okay, so this is going to be a good video about the different ways to power your Arduino board. Okay.
Arduino-based project, it's super important to be able to power the whole project, including the Arduino. But how do you do it correctly? In this video, I'll walk you through how an Arduino actually gets its power and how you can power any Arduino project, even if it uses power-hungry components or even multiple voltage levels. Let's take a quick look at the three main ways that an Arduino can receive power so we can understand what's happening when we do power one. I'll assume that you're using an Arduino that accepts 5-volt power. First, we have the V-in pin, and on some Arduinos, a positive polarity barrel jack as well. Both of these options allow you to supply a higher voltage than 5 volts to your Arduino. This is then fed into the onboard voltage regulator, which steps it down to the 5 volts that your Arduino needs. On common Arduino models, you can supply anywhere from 7 to 12 volts through either of these inputs, but some Arduino models do have other requirements. Next, we have the USB port. This is the most common way to power your Arduino during development. It's convenient because it also allows you to upload your code and monitor serial data at the same time. When this connector is connected to your computer or a USB power adapter, the Arduino receives 5 volts from the USB port. Notice in this diagram that the USB port bypasses the voltage regulator. That's because any USB device already supplies 5 volts. But what would happen if you were to power the Arduino through the V-in pin and then also plug it in through USB? A big bang and a fire, right? Actually, no. The Arduino is very clever and cuts off drawing power from the USB port if it's being powered through the barrel jack or the V-in pin. This is done through a simple P-channel MOSFET which switches off when it detects around 6.6 volts at the voltage regulator input on the Arduino. And what's even cooler is that it's only the power line from the USB that's being disconnected by the MOSFET. Your Arduino will still be able to talk to your computer through the USB when powered this way. The last and most interesting way to power an Arduino is through the 5-volt pin. This bypasses the voltage regulator entirely and connects directly to the Arduino's 5-volt rail. If you connect a 5-volt power supply to this pin, you are effectively providing your own voltage regulator. This can be very useful for larger projects that already use a 5-volt power supply, and I'll be showing you exactly how to do this in this video. Now let's jump into 3 common ways that you can use to power an entire Arduino project, including projects that have higher power components. And if this video is helpful, make sure to like and subscribe to help this channel grow. If you have a project that only needs 5 volts or 3.3 volts and needs less than an amp, you can actually power your project through your Arduino and run the whole thing off a USB charger or another power supply. Here's a very simple example on a breadboard. This is an Arduino Nano clone, and here's that 5-volt pin running to the power rail on the breadboard. And then, of course, I also have the ground pin connected to the ground rail so that we're able to complete a full circuit. When I hook up power through the USB port, for example, the LED lights up. And that's because the Arduino is feeding 5 volts to the power rail on my breadboard, and that in turn powers the LED. As long as I don't exceed the current limit of either the Arduino or the USB power source that I'm using, this is a great way to power a project. When using this approach, I prefer USB because USB chargers are just so ubiquitous these days, and some of them are nice and compact. But if you prefer, you can use V-in or the barrel jack with a 7 to 12 volt power supply instead. There are a couple gotchas to watch out for. Most Arduino boards can supply up to an amp this way, but there are exceptions like the Nano, which is only rated for 0.8 amps. Secondly, the power supply that you are using must also be able to handle your project's current needs. Many of the older bricks used to only support half an amp, so make sure to check the back. Older USB ports are also limited to half an amp if you're planning to power this off a computer. Now, what if we need to power a project that uses more than the 1 amp of current that the Arduino can supply? For example, powering a solenoid using my handy solenoid tester. There's a couple ways to handle that. In this section, we're going to use a higher voltage external power supply and the V-in pin of the Arduino in order to power it. This is a great approach if your project already uses a higher voltage such as 12 volts and you're trying to figure out how to use that same voltage supply to power the Arduino as well. To make this work, your external power supply needs to be in the voltage range that your Arduino's voltage regulator accepts. I've got a 12 volt brick style supply that I'll be using in this example. In this scenario, the barrel connector is supplying 12 volts to the power rail, so this is no longer 5 volts. To make the Arduino work properly, I've now connected the V-in pin on the Arduino to the power rail. Notice also that ground continues to be connected to ground. That does not change. The advantage of this setup is that the electronics on the Arduino are no longer powering our entire project. Instead, we have an external power supply that is capable of supplying more current than the 1 amp that the Arduino can do. And the Arduino can still control the solenoid using this MOSFET here. If you're curious how and why this works, I do have a video all about controlling solenoids using an Arduino, so be sure to check that out as well. A few things that you should know when using this approach. Just like in the previous example, it's still perfectly fine to use that 5 volt pin that I showed you to power other 5 volt parts of your project, as long as you don't exceed the Arduino's current limit on all of your 5 volt parts. Next, be very careful when wiring up projects like this. Again, this is 12 volts here, so if I were to take this power rail and connected elsewhere on the Arduino, such as the 5-volt pin, then I would damage it. It's also important to realize that V-in does not have polarity protection, so you don't accidentally want to miswire things. Lastly, this is a good time to mention that I'm using breadboards throughout this video because they make it really easy to see how you can build these circuits and wire them up. However, breadboards are not actually a really great choice for higher power projects because they themselves can only handle about an amp of current. So if you're building a project for real that uses motors and solenoids or whatever else, you are probably going to want to solder it together on a perf board instead. Let's move on to a slightly more advanced but more flexible method of powering your Arduino, using an external 5-volt power supply connected directly to the Arduino's 5-volt pin. This allows us to bypass the Arduino's voltage regulator and allows us to supply the Arduino directly from our own 5-volt power source. Here's an example that may seem familiar from our first demo, but it's slightly different. We once again have the power rail connected to the 5-volt pin of the Arduino, and of course ground continues to be connected to ground. However, this time, instead of trying to power the circuit by connecting power to the Arduino itself, such as through the USB port or the V-in pin, we are going to hook up a 5-volt power source directly to this power rail. This is running off a USB charger, but it can be any power supply that's 5 volts. And we can see what happened. The lights on the Arduino went on because the Arduino is receiving power, and our LED, of course, lit up as well because that's connected directly to the power rail. In fact, I can remove this Arduino board from this breadboard entirely, and this LED will stay on because the Arduino plays no role in distributing power to the rest of a project. This frees us up from needing that 7 to 12 volt supply that the Arduino voltage regulator requires and allows us to power the whole project once again off only a 5-volt supply. But this time we are not limited by the Arduino's current limits and can build a project that uses 5-volt motors, maybe large LED strips, and all sorts of other things, and everything can still work. This approach of powering your Arduino through the 5-volt pin opens up some interesting possibilities with using multiple power supplies in your project. Let's take one more look at the solenoid demo that I was showing you before. What if, instead of using 12 volts, I want to feed 24 volts into this solenoid? That'll give it a little bit more oomph, and as long as I don't power it on too long, it'll be totally fine. The problem with this scenario is that the Arduino's voltage regulator can only accept 12 volts. So it's no longer going to be possible to power the Arduino off the 24 volt supply. Here's how we get around this problem and make everything work. I've got 24 volts coming into this breadboard. This is only responsible for powering this solenoid. The Arduino never touches that 24 volt rail, as you can see for yourself. Instead, I've got a second 5 volt power supply that you saw in the last example on this second power rail, and this is the power supply that actually powers the Arduino. So I've got the Arduino connected here through its 5 volt pin to the 5 volt supply and not the 24 volt supply. So don't mix those two up. Also, if you are going to be using multiple power supplies in your project, you normally need to have the grounds of those power supplies connected together, unless it's a special case like the two are completely electrically isolated. But in this case, this is critical, or it could damage a lot of things, including your Arduino. With this setup, the Arduino can be happily powered from the 5 volt power rail, and of course, just like before, it can interact with a solenoid through this MOSFET, and again, there is a video that explains how all of that works. This is actually a pretty typical scenario for larger projects. You'll often have one power supply that's 5 volts or 3.3 volts that powers all of the electronics in your project, and then you may have one or more power supplies that offer a higher voltage for the components that need them. A few more things you need to know if you're going to power your Arduino through that 5 volt pin. For starters, make sure that this is in fact a 5-volt stable power supply that you are using. You can't use batteries when powering your Arduino this way. You can't use a power supply that's a higher voltage. It has to be 5 volts. If you're using this approach, under no circumstances should you also try to power the Arduino through the V-in pin or that barrel connector. That is going to cause problems and could possibly damage the voltage regulator on the Arduino. The Arduino website actually warns about this specific scenario. The Arduino website also doesn't recommend connecting anything to the USB port of your Arduino when you're using this approach to power it. There are some nuances to this, but if you want to avoid breaking anything, it's best to make sure that you disconnect the Arduino completely from your project before programming it. Let's touch on batteries quickly. If you're building a portable project, then being able to use batteries is a must. But it's not quite as simple as you expect. In fact, if you want to see a full-length video on the topic of powering battery projects, leave a comment down below. If you want to power your project off conventional, non-rechargeable batteries, then a 9-volt alkaline battery is your best bet. Since a 9-volt battery's working voltage is within the range that the Arduino's voltage regulator accepts, you can add a 9-volt battery connector to your project pretty easily. For example, I made my own 9-volt to barrel connector cable here. You can buy them as well, and that makes it very easy to connect it to this Uno clone. And just like that, it's powered. Another increasingly popular option to power an Arduino project is using LiPo batteries such as this one. However, these batteries can be way more dangerous than alkaline batteries because they tend to catch fire. For example, if they're overcharged, discharged too much, or damaged in any way. To use them safely, it is very important to use a battery protector circuit of some kind. The safest way to use them in an Arduino project is to buy one of the newer Arduinos that actually has a separate battery connector on it that has all of the required circuitry to manage the LiPo battery properly. It can even charge it, allowing you to create a rechargeable project. Hopefully that demystifies powering your Arduino projects. If you have questions or you build something.
Okay. I hope that you all found that educational. One thing that I wanted to comment on before I open for comments or questions on what we just showed there, is one thing that I found out separately from this video is that whenever you want to power your Arduino via the 5-volt pin, providing 5 volts as input to the Arduino, that the video is incorrect on its use, that you can't use a battery source as an input for that 5-volt pin. You can use a battery provided that it's regulated at a stable 5 volts. I did verify that, and as far as I know, the video content is correct except for that one point. Okay?
Well, I think he was just assuming that an unregulated battery. You wouldn't want to
Right. Oh,
find
sure.
a battery that was rated at 5 volts and use it
Right.
because it doesn't have a regulator.
Right, exactly. That's right.
in fact,
Anyway, so I just wanted to, because I noticed that right off whenever I was listening real close to the video, because he made it sound like you can't use batteries at all when powering as an input for that 5-volt pin. So I just wanted to clarify that. Okay, I thought that was a very great education video. That's why I decided to show it. Okay. Did anybody have any, especially to do with LiPos, use of LiPos with these Arduinos, etc.? Does anybody have any questions or comments on that video?
So I figured that this 7.4 volt battery is within the range of 5 to 12 or whatever. So I
Yeah, 7 to 12 is what the
12,
VN pin requires.
Might be able to just connect it directly into the regulator on the Arduino board. But then we have the problem that I've noticed a lot of SRS people have this problem that when their motor kicks in, it um, resets their microcontroller. And so
Right.
I want to try and tackle that directly to see if I can avoid that. And my intention is to use a filter capacitor and a diode so that when the spike, the downgoing spike uh, on the supply occurs, the diode should isolate the capacitor from the
Mm-hmm.
battery.
Mm-hmm.
And as long as the capacitor is large enough, it should continue to power the microcontroller. Um, and that should fix it, but we'll see how well that works. A lot of
Mm-hmm.
people I notice, their solution is to simply use two separate batteries, but it shouldn't be required. There should be a
Right.
workaround that would
Right.
work.
Well, yeah. So just as a point on that, Doug, is that any really for any robotics type literature that you read, is that what's always recommended is that you have at least two separate supplies for your robotics projects. You have one that is dedicated specifically to the real noisy electronic parts, for instance, motors or other types of actuators that are real noisy. And you always have that usually at a higher voltage. And then you have your separate supply that is only for the delicate electronics like your microcontroller. That's always, and then have your grounds connected together that to
Well, that's what
avoid
I'm
a
saying.
ground to avoid a ground loop kind of thing. So what's always advised as far as the separateness of the power supplies.
Yeah, that's what I'm saying is that that's often what is recommended, but I don't see why you shouldn't be able to provide a stable supply to the
Okay, that's fine.
microcontroller.
I'm just I'm
What I
just
mean.
stating what it is
Yeah.
that I personally have always used and I've used with success, and what I've read is the general methodology. Okay.
I suppose part of that is that you may want your microcontroller to continue to operate when your motor drive battery has gone too low, and
Right.
so
Right.
that's one thing you avoid by doing it that way.
That's right. Right. Okay.
I can show you what I did with mine, because it is using just one battery.
Hmm.
I have two voltage regulators. One is just dropping it down to 6 volts for the battery. And then another one is taking that 6 volts and dropping it down again for the microcontroller. And a lot of times what I'll end up doing is put a capacitor, right? Just one capacitor, electrolytic, right here near the input of the microcontroller to kind of um, it so it doesn't have those peaks, so it won't brown out. That's always
Mhm.
worked for me. Just putting one right there.
Okay.
So,
And which pin is that capacitor connected to, John?
Oh, just the voltage input on the mic.
Okay. So in other words, like the VN pin, is that what you're?
Yep.
well, VN or 5 volt, which are you connected to?
Well, it's the 5 volt on this particular microcontroller,
Right.
which supplies the power to it.
Right. So, what was the first regulator? Is that because your power supply that you bring to the board is more than 6 volts?
Yes,
Okay.
and I wanted to
Oh, I see. You need 6 volts for your steering servo.
yep, this is
That.
for the not for the servo and for the motors.
Oh, yes. Okay.
Mhm.
So you didn't want to run your motors at the unregulated battery voltage.
Correct.
Hmm.
So it's just getting so that way
So do you have three bridges?
as the battery drains, I'm not going to be like
Right.
the speed's going to stay the same, whatever. So
Do you have three H bridges then?
no, just two. So because I'm just running this uh power to the servo is coming off 6 volts.
Oh, that's right.
Okay.
Well, you get that from the Arduino, right? It's sending the pulses. Actually,
And
no,
then I get, yeah, then I get the actual um
supply to the servo
the
from.
signal, yeah, the signal is coming right from the microcontroller.
Hmm.
And it's just 3.3 volts because it's this ESP32.
Ah,
So the signal on it's only 3.3, but it's still enough to drive the signal on that servo.
that's good.
But yeah, I've had a lot of times where I ran into where the microcontroller browns out and I've always just stuck one capacitor right there, nearest as close to the microcontroller as I could get it, and that seems to have always solved the problem for me.
So I figured that should work, but in addition, if that didn't work, then I would add a diode.
Mhm.
But a diode will drop another zero point 0.7 volts if it's a silicon diode, so you have to account for that. But that way, if the motors drag the battery down um, a significant amount of time, then you want the capacitor to be large enough to continue to run the microcontroller, and the diode then keeps that capacitor from being discharged by the motors.
Interesting.
Okay. Um, one thing that I skipped ahead and showed the video before, I wanted to comment about some recommended tools that I recommend for moving forward. Maybe you guys already do this, but I just wanted to make some suggestions here. Is that what I love to do, especially when I'm starting a new project and I know that I'm going to have to be doing a bunch of research and I need to make periodic notes about code that I want to implement for it and or diagrams and just kind of general ideas is that I always get myself one of these notebook kind of and I have these, dedicated. I have one of these like dedicated to each individual project that I've got in my pipeline. And I keep a library of these. And what I recommend is the graph, the graphical display graph rule type are great for projects like this. I know a lot of people love electronic notes, and I think that that's great. It has its purpose, but a lot of times I also find that it's better to have handwritten notes, especially when you're in the exploratory phases of a project. So that's one thing that I recommend. Okay. And then as far as electronic type of tools and applications, I don't know if you guys are familiar with the old Microsoft project as far as tasks and project organization and all that. But there is a great free app that I frequently use for my electronic projects called To Do List. The website is abstractspoon.com. It's a completely open source application that's installable on your device. And what's so great about that is it's a light version of Microsoft Project where you can define individual projects that you're working on and map out in detailed milestones and tasks and subtasks and even assign individual people if you have that type of a project. And it's real handy for developing your to-do list, either for a particular day's worth of work on a project or for projecting out into the future to get your projects done. So again, I'll be putting that information into the chat for your reference information, but I personally find that app to be extremely, extremely flexible. The other thing, I've been kind of uh, hesitant until late about using Chat GPT or a lot of AI assist for my electronic work. Specifically, I'm referring to Chat GPT. And I have recently found that that's an extremely helpful tool as far as researching hardware and software options, especially in the Arduino and hobby electronic spaces. It's got a lot of great quality, readily available information that we can pull from within ChatGPT. And I'm talking about just the free application, not the $20 a month version of ChatGPT. And so what I've been able to do on multiple occasions, especially with this little toy truck that I'm working on the conversion for, I had several questions about advice from it that I wanted to input in. And it's been great about providing great practical hardware and software solutions to the questions. So I just wanted to get that out there, that is a great resource. More than likely you guys are already using it, but I wanted to point that out.
I've
Okay.
had good luck with Bing Copilot for the same thing. So if you use Bing, there's a Copilot button, and I use it whenever I have a problem with any software, really. It serves as a manual. It sometimes hallucinates, like any of these.
Right, exactly. Right.
But if you hold it to if you say no, it doesn't really work that way, it will eventually do the right thing.
Mhm.
And so yeah, I've had good luck not needing to work with other manuals, basically, not try to look anything up online, just ask the Copilot and it will
Right,
direct me to what I need. Uh,
right.
you know, if it's something related to your operating system, you need to give it the version of the operating system, and sometimes it'll still give you the wrong answer, but it's better than
Uh-huh.
trying to have to look it up.
Right, right. Anyway, so just wanted to get that out there. Um, okay. So some other points specific to working with the Arduino, like the Arduino IDE, and getting, writing your code, compiling it, and then downloading it onto the Arduino board. I wanted to discuss a little bit on that process, since we do have this is, now we're getting into the space with these motor controller boards, etc., where we need to have a separate power source for the motors and the motor controller board, separate from the USB attached cable for our programming environment for that hooks on to our Arduino board. So I wanted to talk a little bit about the process that I'm currently using and what I recommend for some gotchas and different ways of developing the code and then downloading it, and then with or without keeping or removing that USB cable to either debug, to use the serial monitor and all that kind of stuff, and just some general information about that. That was another thing I wanted to talk about. So, in general, what I've been doing is I don't hook any external power at all onto my Arduino board whenever I'm developing any kind of code for it. I literally just develop the code, compile it, and then download it onto the Arduino. And then I literally remove that USB cable, do all my external connections to the board, including separate power sources, and the power source either through the VN pin or the barrel jack. I haven't used the 5-volt pin thus far for actually powering the Arduino. That's going to be a next step for experimentation. But what I've been doing for the power source external from USB is using either the VN pin or the barrel jack, okay, for my battery pack, okay? And supplying, in my case, since I'm using either the Uno or the Mega, that requires the 7 to 12 volts. Okay, so I've just been doing the connection for that for the battery pack. Okay, and then what I do then is I literally power on the board. I usually have an on-off switch for the power source because I just always hate literally just plugging something in to the Arduino. It just, to me, it's always a way of negatively zapping the board. So I always like to have a physical toggle switch to power that on after I've done the firmware download. Okay, and then I go from there. So what's recommended is that you can either remove the USB, and of course then there's no IDE debugging that can go on. You can't use the IDE anymore to interface with what it is that you've got loaded and attached to the Arduino board. Okay. And let's see. Okay. Or you could keep the USB cable attached after you've done the download of your code onto your board. And then this allows for the IDE tools like the debug monitor, etc., of the running code. And then you can also then hook in your 5-volt power source or your external, your power, and then your separate hardware. And you can do that. So in other words, you can run externally, you can both run, and I think they mentioned that in that video. You can both utilize the USB cable being attached, utilize the debug tools within the IDE, and also be separately powering the Arduino board without any conflicts. The board is smart enough to separate and allow for all those different communications to happen. So you can do that. It's just what I remember with that video is that you need to be careful about supplying power with that 5-volt input pin and then not having USB connectivity going on at the same time.
So,
And that's,
I caught that from the video. Now I finally worked it through in my mind. The MOSFET is there to protect the case of having USB connected and the
Mhm.
12-volt supply connected, but it doesn't protect for the case of the USB connected and your external 5-volt supply being connected. That's what
Right.
I'm warning against. So,
Right.
yeah, if you wanted to do that with USB connected and an external 5-volt, you'd have to cut a trace basically. You'd have to
Yeah, right.
you
Right.
could independently power that MOSFET, but that would take a whole nother power supply. So that would I don't know.
Right. Right. Yeah, exactly. So anyway, I'm just trying to say that there's some caveats to all this as far as what you do with your Arduino board after you've downloaded your code on there, and then all the different debug options, and with the USB cable being it's still attached, and then all your attached peripherals. I'm just trying to say that there's some things that you need to be aware of there in being able to do that successfully.
You could
Okay.
imagine making a plug-in socket, a USB plug-in socket that didn't have the battery plus, or not battery, but the +5. You could not connect that between those two connectors and then put that in the line, and that would protect the Arduino from receiving 5 volts from two supplies.
Mm-hmm. Right. Right. Okay. Anyway, so I think enough on that particular topic. Another thing that I wanted to talk about today is shields. That's just the kind of the generic Arduino term for extra boards that we can literally stack on top of your baseline Arduino hardware. Okay. And specifically, I want to talk about shield stacking and some things that I have personally found since starting this project with using shields. Okay. In general, what the Arduino community tries to advocate for is that in theory, you can have a lot more than just one shield of a particular function that's providing a particular function to your project and have multiples of them literally physically stacked on top of one another, provided that the form factors are okay and all that. But in general, I have personally found, and other resources that you can find online recommend this kind of thing as well, is that in general, you just want to, whenever you're using a shield, that they are not necessarily as great as they originally sound. Number one, because of the number of pins on the on the Arduino board itself that the shield is requiring its use of, is that can be a preventative of if there's some kind of sharing between more than one shield that's using shared pins that would, I'm sorry, I'm not explaining this well, that's using pins, the same pin, there's likely to be conflicts whenever that's going on. So in general, whenever you're using shields, it's usually best to just plan on using one shield per Arduino board. And for more complex projects, to have more than one Arduino or Arduino and other types of microcontrollers that form the totality of your project. And then you can have individual shields or other components that are fit into your project model. Because just specifically for the idea about, unless we're talking, now a lot of the shields that are prevalent out there, like motor controllers, in addition to I/O pins, like if we're talking about analog pins or digital pins, those are just natural, that the shield is going to require that use of the Arduino board. But in addition to that, there are there's the I2C protocol pins that are on the Arduinos that they use. So if you want to use, if your project, for whatever reason, really mandates a single Arduino and multiple shields, physically stacked or not, if you have more than one of those shields, you're probably going to be okay as far as shareability of multiple pins for all of those shields with the single Arduino. You're probably going to be okay if the only sharing of pins are only related to, say, I2C. Because with what's so great about I2C or SPI is that you can set up your system with the Arduino as the master, and then the individual boards or shields that are slaves to it. You can set all that up that you can have all of those shields with one Arduino and make it all work. But that's really the only way that you can avoid the conflicts as far as pin sharing and make multiple shields work with a single Arduino, because of all the pin sharing, etc. That can happen. So you need to be very, very acutely aware whenever you pick out your shields and physically go to plug those in with your Arduino. You need to make sure that you research and fully understand what pins on your master Arduino device is that shield really dependent on. And then work back from there and identify Is that shield using SPI? Is it using I2C lines on the Arduino? All that kind of stuff. Ultimately, you want to make sure that you don't have pin conflicts. Otherwise, if you do, things are not going to work right. So if I'm just saying that you really got to be careful about shield stacking.
I got a lot of practice on that. When I bought this Arduino kit, it had a tutorial, and I've got the first 12, I think it is, projects all built on the same Arduino setup. And in order to do
Mm-hmm.
that, I had to modify the pins that each of those was using so that I could have them all connected and not interfere with each other.
Mm-hmm.
But I can see that if you were stacking them, you don't have the option to do that, or necessarily anyway, unless they've gone to some trouble on each of the shields to allow you to move the pins around. But if you didn't physically stack them, you could imagine running the wires to different pins, basically, right?
Right.
Shield
Right.
that goes pin 3 and 4, and you just move it to a different pin that isn't used.
Right. Right.
Are
So
there probably for want of a better word, I would call it a motherboard, but the idea would be to have multiple shields that are isolated from each other, controlled by one Arduino. But I don't know if it's worth the trouble to actually have a board for that purpose. Um, you just basically need to use wires to connect them.
right. Yeah. And as I said, the caveat to all this to making a single Arduino system control multiple shields
Hmm.
using that one Arduino as the master, that really the only way of achieving that is through the protocol like I2C, that kind of thing, where you've got the master device being the Arduino, and then you've got all the different slaves that have their own unique I2C address that are on that bus with the Arduino as the master. And then if provided that there are no other pin conflicts, or you can, you know, um, turn things on or off, so to speak, with the individual shields in turn for the conflicting pins, IO pins, for example, then in theory, you could make a single Arduino system work. But I'm just trying to point out that there are lots of problems with this whole idea that's been advocated from the start of the Arduino craze. The idea about multiple shield stacking scenarios being successful is kind of a misnomer. That's what it is I'm getting at here. For whenever you go to practically apply that. So I'm just letting the listener beware here, because you need to make sure what it is that you're getting into for actually using all the individual shields that you want to use in your project. So, okay. Okay. And so the only other thing that I specifically wanted to comment on is back to my original statement that I started off with in using my particular uh, inexpensive RC vehicle that I was in the process of trying to convert and be able to keep the original RC PCB on board, and then have my whole user switchable scenario for motor control scheme. Basically, I found out that that's not going to be a doable project because of that 5-pin connector. It's just going to be a whole, even if I could figure out their communication protocol, that the PCB from the transmitter to that PCB to that modified or that pseudo servo motor for steering, even if I could figure out that communication protocol, which in theory I could, with a little bit of debug. The idea then of being able to keep that PCB and then augment it with the Arduino is kind of prohibitive at this point. I'm going to plan on still keeping the vehicle that I'm talking about in my stock for the idea about number one, at a later time, doing that debug and see if I can actually figure out the communication protocol. And then if I do, then literally ripping out that PCB and just literally having it as an Arduino autonomous control vehicle versus the idea about that user switchable scenario. That's really the only way effectively that I can see of using this particular vehicle. So what I plan on doing between now and next meeting is I've got another vehicle on tap. I can't show it to you in my camera view today. That I'm going to be doing the same type of thing. It has on stock, it has for the RC system, it has a traditional transmitter and receiver unit that's on there, ESC and all that. I have confirmed that this platform that I want to use does have just a traditional drive motor or drive and steering motors on it. So everything will work out fine. I don't have this extra problem of for the steering control and all that. Okay. So all that's going to be good to go for me for actually moving this project forward, because what I want to do for my build, for my conversion, is be able to develop that user switchable between RC or wireless control, be able to flip a switch and then have it drive in an autonomous hands-off fashion. So that is my overall goal. That was originally, and well, with this different vehicle, I'm going to be able to make that a reality, but using different RC hardware. I'm going to be using the traditional remote control system parts for the RC part of this, or the wireless control, and be able to use the wireless transmitter that came with it. So that's what my particular plans are in the future for my conversion project. And I'll be using an Arduino, probably an Arduino Mega, in my case, for a larger code base allowance for this system, and then also additional I/O pins than in comparison to the Arduino Uno. So that's what my plans are in future for my conversion. So for next month, I'll be able to share more as far as what I've learned. Okay, that's my plans. But I'm glad, John and Doug, that you guys have viable platforms to be researching and actually implementing with. That's great news. Anything else that anybody wanted to talk about or bring forth or comment on? Whatever.
Well, you mentioned your plans. I think my plan is to get this operating from my phone. So we'll see how that goes. Get it connected. I've already am able to actually connect my to it through the computer, through the USB, and do controls. So the next step is to actually do the same thing from my phone and do some operation that way.
Mm-hmm.
So you're
And that's
using
oh.
the ESP, excuse me. You're using the USB, the US. I've got it. ESP, the ESP's
32.
innate ability to receive Bluetooth. Is that what you're using?
Yes. Yeah. Yeah. I'm not using the Wi-Fi. I'm using the Bluetooth. I know that it is limited range, but I'm not planning on letting it get out of too far away anyway. So
Right.
Mm-hmm, mm-hmm. Right. Yeah. Now, so the one thing too, talking about wireless technologies, I have a set of the original XB capital X and then BEE devices. And so that's one thing too that's separate from RC, the standard of RC for control for wireless. I also want to do some implementations with XB for wireless communications. Because if you're not familiar with that particular type of system, is that they come in pairs, match pairs as far as like the transmitter and receiver parts, and you can set up your own custom switches and inputs to the transmit side of your functionality, and then on the robot itself, then you've got your receiver and the smarts to communicate with the rest of the system. So that is something in future that I want to implement as well with Arduinos and other microcontrollers. So. And I did put into the chat, and I will do the same over in Discord for today. I did put those reference URLs and reference information that I wanted to provide to you guys. Okay.
I do have one other thing I wanted to share.
Oh, sure.
So one of the things I've done with one of my other robots is the ability to get debugging data off of the Arduino and send it over one of the UART connections to my phone. So I can actually, with this cable, it's an OTG cable. It just goes from regular USB type, is it type A or B? Anyway, and then it goes to USB-C. And I can actually connect this to my phone, and then with a TTL to USB, I can go ahead and get serial data right to my phone.
So you have to be wired up to it.
So yeah, so I have this just wired up, and I can connect it.
Now, where do you connect that?
Pardon me?
Oh, so you just pointed to your TTL connections. Where do you connect that?
To the Arduino, to one of whatever UART that I want to use on the Arduino.
I see.
Yeah. So it's kind of nice having something separate. I don't have to have the computer right there. I can have this.
Right.
This can be
right.
mobile.
Yeah.
Yeah.
Right. Yeah. That portable data capture and portable communication is a great asset for us to have and to implement and have at our disposal.
You could probably do the same thing with some type of display that's connected to the Arduino as well. But I thought this was kind of a neat idea too. So I've seen it.
Right. And then also too, sometime in the future, John, after you get your app, your Bluetooth app built that interfaces to your new platform that you're working on, I would personally love it, and I'm sure that the rest of the people who attend these meetings would as well, that maybe you could prepare a bit of a presentation on kind of like a how-to as far as how to develop all that for your phone app, and then all the interfacing and whatnot for the robot or your platform, your mobile platform. That would be great if you could plan on doing something like that in the future.
Oh, okay.
That was something I was thinking about for like a guest speaker kind of an application. Okay. Does anybody else have anything? Because we're about at 3:00, and 3:00 Pacific time. So I don't know what else needs to be shared and talked about today.
I'm good.
Okay. Okay. Well, it's been great seeing you guys today. And I'll go ahead and stop the